Good day, students. In this clip, we're going to be going over two examples on linearization and differentials. Before we get started on the first example, let's go over what linearization means. Again, first, so the definition of linearization, just in brief, if f of x is differentiable at x equals a, then the equation of the tangent line, the equation of the tangent line which is written as L of x equals f of a plus f prime of a times x minus a defines the linearization. Okay, defines the linearization. So what this is basically telling us is that the tangent line is a good approximation of a function at a point really close to a specified x value. Okay, so basically if you zoom in sufficiently close to a point on any curve, that curve looks like a line. As long as the curve is differentiable at that point, the tangent line will be a good approximation of the values of that function. All right, so if you already know how to find that equation of a tangent line, then you already know how to find the linearization of a function, because the tangent line is in fact the equation of the linearization of the function. All right, so let's go ahead and take a look at example one. We're to find the linearization of y equals x to the third plus 2x at x equals 1. Okay, and that's for the A part. And then for the B part, you're to represent your results graphically. And state the significance of your results. Okay, I will also show you how to use the calculator to find the equation of the tangent line or the linearization of the function in this example too. All right, okay, so let's go ahead and do this. First thing I'm going to do is write down my function. My function is f of x equals x to the third plus 2x. Okay, now let's apply the formula. I want to apply the formula to this function, then I'll then focus on this specified x value here. So for x equals a, well, what do we know? Well, let's write down the formula first before I start finding those pieces. So the formula tells us that the linearization L of x, so basically the function can be approximately given by L of x, which is equal to f of a plus f prime of a times x minus a. Okay, all right, so this is the formula that we're going to be using. So if x equals a, all right, if x equals a, then f of a is going to be what? It's going to be a to the third plus 2a. Okay, and then what is f prime of a? F prime of a is what you get when you differentiate this function and you substitute a. Okay, so if I differentiate this, f prime of a, you differentiate this function, is going to be 3a squared plus 2. Okay? So this function helps me figure out the output value of the function at any specified x value, and this helps me figure out the derivative or the slope of the tangent line at any specific value. All right. So in this question, we are to find the linearization at x equals 1. So let's set x to the value of 1. Okay. So that's basically what a is. So a is going to be 1. All right. So if a is 1, f of a is simply going to be f of 1. Okay, what is f of 1 is what you get when you plug in 1 into this function. So you have 1 to the third plus 2 times 1, which is 1 plus 2, and that's 3. Okay, and then you have f prime of a. F prime of a is going to be f prime of 1, which is evaluating the derivative of this function at a equals 1 or x equals 1. So that yields 3 times 1 squared. Remember, you differentiate first, plus 2. Using the order of operations, we'll have 3 plus 2, which is 5. All right? So now we're going to write down the equation of the linearization, or the equation of the tangent line. Now, just to show you a connection, you have actually seen this equation before. All right, let me show you the connection here. So your linearization is f of a plus f prime of a times x minus a. So this is the equation of a line, okay? The point slope form of the equation of a line that you learned in Algebra 1 and 2. So this is simply y equals y1 plus m times x minus x1. It's exactly the same thing, okay? So this basically is y1, and this is a slope. All right, just a real quick algebraic connection for you. Okay, so we are going to put all this together in the formula to give us our linearization function. So we're going to have the linearization of the function L of x equals f of a, which is 3, plus f prime of a, which is 5, times x minus a. A is 1. All right, let's simplify this. So we have L of x equals 3 plus 5x minus 5, and this simplifies into 5x minus 2. So there goes the linearization of a function. The function x to the third plus 2x. Okay? All right, so let me show you how to do this with your calculator. But before we do that, let's graph this by hand and then check the accuracy of our results using a calculator. So I will make a table on the right here, a table of values. I just need 3 points. I'm just sketching the function. So let's x and y. I'm going to use -1, 0, and 1. Okay, and we know y is equal to x to the third plus 2x. If I plug in -1 here, I'll have -1 to the third, which is -1 minus 2. That will yield -3. If I plug in 0 here, I'll get 0. If I plug in 1, I'll have 1 to the third, 1 plus 2, which is 3. Okay? All right. So this is an odd function. So let's go ahead and sketch what the graph looks like. There goes my y-axis, my x-axis. So we have 0, 0, center. -1 goes to 1, 2, 3. +1 goes up 1, 2, 3. All right, so the cubic function, so it curves a little bit like that, and this curves a little bit. Oh, I went a little bit too far. Let me fix that. All right, so there goes the sketch of the function. It's not perfect. So let's go ahead and this is the function f of x equals x to the third plus 2x. Now let's sketch the graph of our linearization. which is 5x minus 2. We can see here that the slope is 5, and our y-intercept b is negative 2. So we're going to start from, let's make this green, start from negative 2, and we're going to rise 1, 2, 3, 4, 5, and run 1. So that will be our linearization over there, okay? All right, so let's go ahead and sketch the line of our linearization. See what that looks like. Something like that. It's much better when you do it with a calculator. Okay, so there goes our linearization. Write down the name of this function we just drew. So this green function is L of x, the linearization of the function, which equals 5x minus 2. Okay? So what's the significance of this result we just came up with? Let's write down the significance. Significance is as follows. Why care about this? Well, the line 5x minus 2 can be used to approximate the function f of x equals x to the third plus 2x near x equals 1. The closer you are to that point of tangency, the more accurate your approximations will be, and the farther you are away from that point, the less accurate it will be. Okay? So why care about it? Well, using the equation of a line is very easy to evaluate messy numbers like fractions or decimals, especially when the function is very, very complicated. Okay? So that's the power of the linearization. Now let me show you how to do this with a calculator. I'm going to be using the TI-89 titanium. So to show you how to do all this process with your calculator, you go to the graphing menu, diamond F1, takes you to the graphing menu, and then we are going to enter the original function, which is x to the third plus 2x. Enter. And make sure your function is accurate. Then let's graph the function, diamond F3. And there goes the graph of your cubic function. Now to find the linearization, all we just have to do is calculate the tangent line at x equals 1. To do that, we hit the math menu, which is F5, and we go down to tangent. See, menu A is tangent. Hit enter. The calculator will ask you for what x value you want to calculate the tangent line at. We're going to specify 1. X equals 1 is indicated here. Press enter. And then you see, not only does it give you the graph, it gives you the equation of the tangent line. And you remember, the linearization is the equation of the tangent line at the specified x value. So you see that our answer here was 5x minus 2. And that is the equation of our tangent line, and that is the graph of our tangent line. Now, how does this connect with linearization? If you zoom in sufficiently close to that point, what will happen is that you will find out that the tangent line and the line of the function are not distinguishable. Okay, so let me show you how that looks. So I'm going to do a zoom box. We're going to keep zooming in until you see what the whole idea of linearization looks like. So that's the upper left corner, enter. Go to the right, just zooming around the point of tangency. Bring it down, 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 enter. So that's the function. So now I want to graph the tangent line, okay? So let me go to the Y menu and enter 5x minus 2. Enter. And let's graph it. You see how they are looking like the same function? Now let's zoom in a little bit more. Okay, let's zoom in a little bit more so we can really see the power of the linearization function. All right. So go to the left, look. We're picking points around 1, so you'll see what will happen at x equals 1. So enter, that's the lower right. Move it to, lower left, move it to the right. So point x value above 1, and then stick it higher. Right there, enter. So the first thing to be graphed will be the cubic function f of x, graph. And then the next thing will be the tangent line. Okay? Now let's do a trace. F3 at x equals 1, enter. You see at x equals 1, they're almost exactly the same thing. And you notice how close the approximation is around that value, and then as the x value gets further and further away from 1, they start to diverge. Okay, so that's the power of the linearization. It tells you that at any point close to the point of tangency, that tangent line can act as the function. Okay, so that's that. All right, let's take a look at another example. Question number 2. In this case, we have f of x equals sine x. We have a trig function in this example, okay? And we are going to find the linearization at x equals pi. All right? So the first thing we're going to do, let's rewrite the function. The function f of x can be approximated by the linearization, which is f prime of a, f of a plus f prime of a times x minus a. Okay? All right, so let's say that x is equal to a. All right, I want to apply a to this function and see what it looks like. So f of a is going to simply be sine a, and f prime of a will be the derivative of sine at x equals a. So what is the derivative of sine? Is cosine. Cosine x at a is cosine a. All right, so these two values can help you find the equation of the linearization for any arbitrary x value. Okay, now let's fix it. Now what if x equals pi? Okay, so that's what we want to pick a at. Let a be pi, or x equals pi. So f of a will now be f of pi. F of pi is what you get when you evaluate sine at pi. Sine of pi is what? Sine of pi is 1. If you think about your trig function, sine starts from the middle and goes like that. Actually, sine of pi is 0, sorry. Anyway, sine of pi is 0, so sine pi equals 0. And f prime of a is going to be f prime of pi. We're finding the slope of the tangent line at x equals pi. So we're just simply going to be inputting pi into the cosine, or the derivative of sine. Okay, so it's going to be cosine pi equals -1. If you think about it, let's sketch the cosine curve. I like to sketch my curves when evaluating trig functions at the axis. So it goes something like this. And this is pi right here. And the minimum, we know the minimum of the cosine function is -1. All right, so we have all the ingredients to assemble to create our linearization function. So L of x is going to be f of a, which is 0, plus f prime of a, which is -1, times x minus a, which is pi. Okay, so if we simplify this, we're going to have the linearization L of x equals -x plus pi, and that's your final result. All right, so what does this look like? What does this look like graphically? Let's go ahead and sketch our graph, and then state the significance of our result. Okay, so we're gonna graph the sine function. Let's call this pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then let this be the maximum 1, and then the minimum 1, 2, 3, negative 1. So we start from the center to the max, to the center, to the mean, to the center. That pattern basically continues. So let's draw a sine function like that. It's just a sketch. Down. Okay, the pattern basically continues forever. Now this right here is the point that we are finding the linearization at. So we have negative 1 plus pi, so we can see that m is negative 1 over 1, and our y-intercept b is pi. Okay? Okay, now to graph our y-intercept, we need to stretch out our y-axis a little bit higher. We know that b is approximately 3.14. Okay, so this is 1, 2, 3, and then we can say pi is somewhere around here. Okay, so let's say this is b, and then let's do this in green. So this is b, so we go down pi units, and then we run pi units also. All right, and then we'll draw the graph of our line. This is just a sketch. Let's make it green. So from here to there. Okay, if you do it with a computer, it comes out perfectly. This is just a sketch. So that's our linearization. Okay, let's label and state the significance of our result. This is the linearization L of x given by the equation negative x plus pi, and this is the function f of x, which is sine x. Okay, now what is the significance of what we just did? Significance. All right, so the significance is as follows. The significance is that the line, or linearization L of x equals x negative x plus pi can be used to approximate the function, the original function f of x equals sine x at points close to the specified x value, which is pi, at points close to x equals pi. Okay, so that's that. All right, let me show you how to do this with a calculator again, just for more practice. I know you already know how to do it, but you can get too much practice. So we go to the y menu again. Let's clear out the linearization of the other function and the other function. We're going to input sine x. Okay, that's the original function. We're going to graph it. I'm going to press on to interrupt the graphing process. I need to reset my zoom into a favorable coordinate setting. Since we're graphing a trig function, we're going to use zoom option number 7. Okay, so let's select 7, and there goes your nice sine function right there. So we're looking for the linearization at x equals pi. If you recall, you go to F5 and you just look for the tangent line at x equals pi, because that's basically what the linearization is. So we go to the tangent menu, have it highlighted, press enter, specify the x value at which you want to find the tangent line or linearization. In this case, we're using pi, so I'm going to enter pi, and then it's highlighted here. You press enter, and there goes the graph. Just matches this perfectly, and the equation negative x plus 3.14159 or negative x plus pi. Okay, so that's that. So thanks so much for taking the time to watch this presentation. You can always feel free to subscribe to my channel for other cool calculus clips such as this. And please post a comment to let me know what you think, or give me a thumbs up if you liked it. I appreciate it. More clips can be found on math.serve.com, Thanks again for watching and have a wonderful day.